Recommendation 2 in the Teaching Strategies for Improving Algebra Knowledge in Middle and High School Students Practice Guide calls for teaching students to utilize the structure of algebraic representations. By structure of algebraic representations, we mean the underlying features and relationships among quantities, variables, operations, and equalities or inequalities. Paying attention to structural similarities helps students make connections among problems, solution strategies, and representations that may first appear different but are actually mathematically similar. With an understanding of the underlying structure, students can focus on the mathematical similarities of algebra problems that appear to be different, which can simplify solving them. For example, though these equations seem different, they all have a similar structure. 2 multiplied by a quantity plus 8 equals 14. While this example involves similar structure across 3 equations, structural similarities can also be found in word problems requiring algebraic representations. To support students in noticing and leveraging problem structure, model and encourage the use of precise mathematical language that reflects the algebraic structures you're teaching. During whole class instruction, you can model the process for solving a problem, for example, using the distributive property to multiply 2 binomials. Here, we have 2 binomials, and each consists of the sum or difference of 2 quantities. We can use extensions of the distributive property of multiplication over addition to rewrite the expression. We can then distribute to multiply each binomial, 2x and 5, over the binomial. Carrying out the multiplication, we have 8x squared minus 6x plus 20x minus 15, or 8x squared plus 14x minus 15. Modeling precise mathematical language while noticing mathematical structure in solving a problem helps students understand the mathematical meaning behind the solution strategy. When teaching students to utilize the structure of algebraic representations, encourage them to use reflective questioning, or questions that help students look back over what and how they've learned to notice structure as they solve problems. First, model reflective questioning to students by thinking aloud or being metacognitive while solving a problem. Then, ask students to respond to reflective questions in writing as they complete their algebra work. Consider posting common reflective questions on the wall or circulating a list of common questions students can use. In this example, a pair of students started by asking themselves about the form of the expression. They noticed that it is a sum of 2 terms with a common factor, which led them to perform their first step using the distributive property. By discussing questions about the problem, these students are thinking about the structure of the problem and potential strategies they could use to solve it. Consider explicitly teaching how different algebraic representations can convey different information. Recognizing and explaining corresponding features of algebraic structures can help students understand the relationships among equations, graphs, and word problems. You can present equations in different forms and ask students to discuss similarities and differences in pairs. For example, when teaching linear equations, you can show the equation of one line in 2 forms. Group students into pairs and ask them to discuss the similarities and differences between these 2 forms. Using multiple representations of a problem helps students recognize different ways the information can be displayed. For example, A problem about two adjacent garden plots can be displayed in multiple ways: in words, explaining the real-world problem, including known and unknown quantities; in a diagram, with key variables and quantities; in an equation; or as a graph. Encourage students to translate problems across representations in order to better understand their structure. When I first implemented this recommendation in my classroom, I was worried that I wouldn't be able to get my students to slow down, pause to ask themselves questions, and really think deeply about problem structure. They tend to race through problems. To address this, I assign tasks that require students to respond to reflective questions. Sometimes I only ask students for their responses to reflective questions. I didn't even ask them to solve the problem. They seemed to be very engaged when I had them use cooperative learning structures such as think, write, pair, share, or numbered heads together. I also began to challenge students to solve problems in more than one way and to explain the differences between their solution strategies. I noticed that my students began to slow down during their problem-solving process and consider alternative strategies as they completed their algebra assignments.